right. Hey, everybody. Welcome to the live stream. I got Johnny Winters here with us. So excited. We're going to be talking about Lakehouse and what the heck it is, how you can use it, all that great stuff. Hey, Johnny, welcome to the show.
Hey Chris, how's it going?
I'm doing so good. Thank you so much for taking time out of your day to come and join us. You want to tell everyone who might not know you where you're from, where you're at, what you're doing?
Yeah, no worries. So my name's Johnny Winter. People of the internet might know me from Grayskull Analytics. That's what this logo here is. So Grayskull Analytics is my website. I've got a YouTube channel as well. I do mostly nerding about Power BI. Is effectively what that website is all about. So there's a blog there and what have you. It's just a hobby. So some people think that Grayskull Analytics is my full-time job. It absolutely isn't. My full-time job is actually I work for a company called Advancing Analytics. So Advancing Analytics is a consultancy. We specialize in data engineering and data science. I recently joined as their analytics specialist, which effectively is code word for being their Power BI nerd as well. So yeah, my preference is nerding out about Power BI. Advancing Analytics, actually, we specialize in the Lakehouse. So I've kind of come on board to start building analytics on top of Lakehouses, which I guess is why I feel almost qualified to talk about this particular subject. The other thing as well is the guys at work were telling me off the other day, saying that I put myself down as being just the Power BI guy. I've actually worked in data for like over 15 years, and I've done data warehousing, I've done semantic layers, I've done the whole stack. I just tend to only talk about Power BI because it's the bit that I enjoy the most. But yeah, that's me.
Oh, that's fantastic. Well, excited to have you here, and I've got links that I'm posting to all of your stuff inside the chat as well. So people, please make sure you connect with Johnny Winters or Grayskull Analytics over on YouTube. Like, subscribe to this stuff. I'm sure he'd really appreciate that. And also, are you on Twitter, LinkedIn, any of those places a favorite of yours?
Yeah, so I'm all over Twitter. So that's at Grayskull PBI. I do LinkedIn as well. So my LinkedIn at the moment has been a subject of much amusement for a lot of people. I did LinkedIn hard mode, so I did a LinkedIn post every day, and some of it might have been a bit weak. It was fun doing it anyway. So yeah, I try and keep a bit of a presence on LinkedIn. More fun stuff on Twitter.
Fantastic. And I think I saw your post today. Was that on data pairs?
So data pairs, Mara Pereira's website, I did a post on yesterday. Today was a blog that Ed Hansbury did about calculated columns. We could talk about calculated columns all day, but we probably shouldn't.
Well, all right. Well, I would love to talk calculated columns. That's something I have a particular view on, but that is a completely another topic for another day. So before we get into any of that, I do want to let all the viewers know, hey, we are here, because number one, because I wanted to talk to Johnny, but we're doing this on a live stream because we want to help you educate your knowledge, further your understanding of what the heck this Lakehouse thing is. So if you have any questions for Johnny or myself, put those down into the chat. Put a Q : mark on the front of it so that we see that it's a question for us to ask and answer, and we'll do our best to get to all of the questions on the chat. No promises, no guarantees, but we'll do what we can on this. So before we get into any of that, I'm going to ask us, this is our lunch and learn. So let's raise our glass, combine glasses, and, be your waters, your protein meals, your coffees, your beers, your carbonated beverage of choice. And let's just take a sip before we get up and going. All right. Awesome. Okay. Johnny. Oh my gosh. Johnny, let's let's go in and see. Can you explain to us what the heck is a data lakehouse?
Yeah, what is it? So I guess there's lots of misconceptions about what it potentially is or it isn't. So first thing that I sort of talk about is whether or not is it just a buzzword? Is it just marketing hype? So how, if you don't mind me asking, Chris, how long have you been working in data?
For about 20 years.
Yeah, okay. So I'm 15, 16 years now. And I would say throughout that career, I've seen so many buzzwords come and go around data. Can you think of any off the top of your head? Oh, there was data fabric was trendy for a while.
Was it's
Seems to have gone
still?
away.
It's not. We're not. You calling it data fabric anymore?
I mean, data mesh is doing the rounds at the moment. I know there's a
Yep.
lot of hype about that. And a lot of people just think that a lake house is the same thing. It's just marketing hype. And I guess Databricks, who are the company who claim to have come up with the phrase, definitely just really played on the marketing at first. So they did a really, really aggressive marketing campaign like about 18 months ago. And it was all things like the data warehouse is dead. I was really triggered by it because I don't think data warehouses are dead at all. But they were saying, no, this is the data warehouse killer. We're getting rid of it. They did a campaign on Valentine's Day where they wrote a breakup letter to data warehouses. So they were really aggressive. And it just felt like marketing hype. They've since kind of cooled their stance now, really. So they're actually now talking about the fact that the lake house is the best way to do a data warehouse. And it feels that potentially that kind of initial sort of bow wave of hype around it is sort of getting to the point now. So I think Gartner do their hype curve, and if you look at Data Lakehouse on that, kind of it feels at the point now where it really is starting to gain traction in it, and it feels like it's it's going to be here to stay effectively. So I don't think it is just a buzzword. I think it's a valid data architecture that's here to stay, and I think we're in it for the long run. Um,
Well,
Other misconceptions that come.
hang on, and I'd like to get into understanding why do you think it's going to be here for the long run? What aspects of it do you think are going to be here beyond just a flash in the pan? Because I think you're exactly right. When people talk about data mesh or big data, those terms are great because they're short, they're concise. Executives can remember them to ask the people that they don't know what questions to ask about. They can ask on those. So why do you think data lakehouse is going to be here to stay?
So I guess I've been working with Lakehouse for 18 months ish at the moment. So I've been with Advanced Analytics since last September, but then the consultancy I worked for before that was doing Lakehouse implementations as well. And I guess just from experiencing it and gone through a few implementations, it feels to me like it's the almost natural evolution of where we've been going in the data world. So that's yeah, I think all the rationale for it, all the reasons for it, all the advantages and the recognized disadvantages, it's not necessarily I don't think the message should be everybody should go out there and everybody should have a lake house now. But I think for the right people, it is the right choice. And more, it's the right choice for more and more people as well.
I'm going
Yeah.
to toss out a controversial statement. I think a data lakehouse architecture is the right choice if you have more than 100 employees.
Okay,
I don't think
cool.
there's another or better pattern that you should be adopting. I think the lakehouse is an incredible pattern, and that's why I really want us to talk about this, because if you're going to say what's the size of an organization that runs a data lakehouse today, Johnny, what would your random guess be? Is it a small 100-person shop or is it or no?
Personally, this is personal experience, both, any. And I'll 100% happy to get to that in terms of why I think that is 100%. We could go for it now if you like. We might be preempting some of
Oh,
the other
I might jump
bits.
ahead. All right, let's keep going. Let's keep the conversation going.
Let's come back to it. Let's put
All
a pin
right.
in that, and then like definitely let's get back to yeah, because it's a good point of debate, and definitely I don't think there's necessarily one right answer. So yeah, definitely be good to get your opinions on it as well, 100%.
Sure.
Um, so where was I? Oh, okay, cool. Other misconceptions about what a lake house is. I have quite good fun with people on Twitter and LinkedIn who, when somebody mentions a lake house, they think all they hear is data lake. They don't hear the house bit. And then they come up with all these objections about why data lake houses are rubbish. But all they've come up with is actually all the arguments against lakes, not lake houses. And a lake house is a different thing. It's not the same. It's different. Again, I'll try and I've got a few slides a bit later on just to give us like a brief history of the data platform, and I'll hopefully sort of try and call out some of those differences as well. But yeah, a lake house isn't a lake, and definitely some of the arguments that people give against lake house, they've just got the wrong end of the stick because it's a different thing.
Right, and I think that's very important, because what we're talking about here is, you know, the best of both worlds, right? Your chocolate and your peanut butter together as Reese's Pieces or peanut butter cups, and not just chocolate or peanut butter, right?
I love that analogy, Chris. One of my main clients at the minute is actually Hershey. So I'm in chocolate and peanut butter analytics all day. But yeah, 100%, absolutely.
Awesome.
Yeah, definitely. It's a different thing, and yeah, I'll come to that hopefully and show some of that off. So I guess the other misconception is that this isn't one specific technology. There isn't like one person that sells lake houses. It isn't just one piece of tech. Again, I personally, with advanced analytics, probably most of the time work with Databricks. We do a little bit with Synapse as well. Most of the time, this is still Azure based. We're Microsoft partners, so it tends to be in Azure. But most of the time, we're using Databricks. Quite a few projects mix and match. So we'll have some components of our Lakehouse that we'll do in Databricks, and other parts we'll do in Synapse. From a Synapse perspective, I can't decide how to say Synapse or Synapse. I'm going to go with Synapse. Yeah, some will mix and match. Definitely, Microsoft are now pushing more and more. They're catching up to Databricks in terms of where the platform's at, in terms of being able to implement that as well. But there's other vendors too. There's, we'll talk about one of the enablers for Lakehouse is storage formats, the file formats that we use. There's actually different vendors and different formats out there that we can use as well. So this isn't a one technology stop. This isn't you go out and sign a check for Oracle to sell you a lake house. It's very much a conceptual architecture. It can bring in different components from different vendors. You might store your data. This would be a bad idea for starters, but you might want to store your data in Google Cloud Storage, and then you might want to ingest your data using Amazon Glue, and then you might want to use Dremio for your compute engine to query your lake house. It's a big architecture. It's not just go out and buy a product off the shelf and there's your lake house sorted. So that's, I guess, the other misconception that I'd probably want to address.
Well, and to that point, I think what we're talking about here is we're really talking about an architecture and a structure that is universal in nature, right? In the same way, like, there's open source file types. This is something that is very, the tech is open, right? There's no one technology that gives you a CSV, right? There's, many pieces of tech that do that. So there's many pieces of technology that can help build and breed a data lakehouse, which could even lead, and maybe it's not each of the, different platforms does a different piece of it, but maybe you're in a large organization where you have a multi-cloud strategy and you have teams that are in Azure, you have teams that are in AWS, and you have teams that are in Google. And they're very large organizations, and they can do their work in each of those areas, and you can do a sync between them all, right? So there's ways that you can make that work broadly because it's just a pattern, right?
100%. One of the other advantage of it, absolutely, is this kind of idea of plug and play as well. The fact that actually you can take that architecture and any one component you could theoretically just replace relatively easily. So if I decided that, okay, this is going to show my age. Back when I started my days as an analyst, it was all in Oracle using PLSQL. And then as my kind of career evolved, I moved over to using the Microsoft platform and T-SQL. I think I prefer T-SQL, let's be honest. I always enjoyed working with T-SQL. There always seems to be more resources out there for people to be able to use it. If, for argument's sake, I had all my data in Oracle, but I said, actually, T-SQL is a better thing to use, I'd have to move all of my data out of Oracle into a SQL server in order for me to be able to use T-SQL. Now, one of the things with Lakehouse is you've got this idea of separating storage and compute. So you can store your data in one place and then plug in your compute and change your mind. So again, I've worked on projects where we might have started out using, we've stored our data in a data lake. It's still called a data lake. We tend to do that using Azure Data Lake. And then we might have started out where we've used Databricks as the compute engine for querying it. And then we've decided, actually, we want to leverage some of the advantages of using Synapse serverless instead. So actually, we've changed our mind. Doesn't matter. We'll switch that off. We'll switch this on. We're up and running.
Yeah, and I think that is the brilliant piece of it, is because it's just a standard file format and a pattern, you can use many tools on top of it. And when, okay, hey, Databricks has been best in class for a while, use that. When all of a sudden you have a solution or a need to use Synapse serverless, you use that, right? I love it. And maybe you've got a slide up. Maybe we should go. And this is something I think would be very helpful for people to go over the brief history of data platforms that you have.
Yeah, go for it. Are we up and running? Can everyone see my screen?
Yes.
Classic. Yeah, so kind of almost the evolution of data platforms. So this is where my data career started. I don't know about you, Chris, but I was all on-premise. My first data warehouses were on-premise SQL Server. We'd use integration services to ingest our data. We'd put that into staging tables in our data warehouse, and then we'd load from our staging tables into our warehouse, and that is what we would use for our BI and analytics. So this pattern has been around for 30, I mean, my data career is 15 years, but this was the de facto approach when I started, and it had been around for 10, 15 years, if not longer before that. So I think most data warehouse professionals would probably recognize the data warehouse. I'm going to have this as our starting point for data platforms.
So I will say that this picture right here, you're right, has been around for 30 years or so. And it's also why I think it's so silly for companies to say that they're no longer doing ETL, but they're doing ELT. Like, liars. This is not something new. This is something we've been doing for 30 years. You just decided to swap the two names out, and then, oh, we're only doing views on top of it. Okay, that works until you have performance issue. But that's a whole religious rant I have against ELT versus ETL.
Yeah.
So this is.
I mean, this goes back to the marketing buzzwords, doesn't it? And ELT is a great example of it. I'm in the same boat as you. It's still just ETL. They're just kind of trying to claim that the order's a bit different. Let's not start on reverse ETL, because that will trigger me even more. And then have you come across the newest one?
No.
Zero ETL?
Oh, come on. Who's doing that? What marketing person
ETL.
out there? Reach out to me on LinkedIn. I want to talk to you. Zero ETL in your buzzwords. Ugh. All right. I'm sorry. Yeah.
100%. No problem. So this is the starting point anyway. So kind of next up here, I've got the data lake. And again, from my career as a data professional, I got myself feet under the table doing data warehousing, and I was pretty comfortable. And then everything blew up in terms of big data everywhere. And it always wound me up, because data is just data. Surely data is just data. I get the whole variety and velocity thing, but the big thing really, really used to wind me up. But everyone was like, oh, well, you need to do everything on a data lake. And this is what the data lake looked like. So rather than storing data in a database and structuring it into something like a dimensional model, we just throw it all in the lake. We'll do schema on read. Rather than designing our schema once and using it lots and lots of times, every time we want to query the data, we'll do the schema at that point. And surely that just sounds like too much effort to me. Why not just define it once and use it lots of times? But schema on read was all the buzz. Lakehouse was the new great thing. People would store their files in the Lakehouse, and they'd store more files, and it was like, well, storage is cheap. We can store everything. And before you know it, the cheesy line here is the data lake turned into a data swamp, and nobody really knows what's going on. Now, again, from my career, when these first came on the scene, everyone reckoned that you should be doing BI and analytics on a lake as well. I think there's been opinions have changed over time, and more and more people recognize that no, it was never really that good for doing BI anyway. BI is better having that sort of structured dimensional model. But it did have its benefits in terms of things like your machine learning and data science workloads and being able to like use this, you still had this idea of separating storage and compute, and you could do these like complex data science experiments over all of these vast quantities of raw data. So I think there's a few things. I think the whole data lakes turning into data swamps, I think, was an education thing. I think if somebody today were to set up a data lake, they'd actually be a bit cleverer in terms of knowing how to structure it better. And definitely a data lake is still potentially a good way to store your data for doing machine learning and data science workloads. So ultimately, if you kind of take the maturity of the data lake and you sort of say that, right, actually, no, we don't really want to use that for BI. We're going to stick with our data warehouse for doing our BI, but we're going to use this concept of a data lake for doing the data science. That ends up being two different paradigms and two different work streams and two separate architectures that don't really talk to each other, but they're two separate use cases, and it kind of works. And they do each have their own benefits.
I just a comment on that to your craziness. This falls under, I mean, not the craziness of the data lake, right? So this falls under, if you only have a hammer or know how to use a hammer, all of the world is nails. All the world's problems are nails, right? And so when data lakes first came out, people were super excited about them, and data scientists were on the cover of Newsweek, and everyone wanted to be a data scientist. And so they said, hey, this is the be all end all is the data lake. And then every CFO on the planet went, okay, and balance and certify our books running a schema on read. And, they had no ACID compliance. They had all sorts of issues with that. And they immediately realized, oh, hang on. It's just a hammer, and it's great for data science, but we still need that heavily structured, that heavily auditable, that ACID compliant environment for work that we do, right? So
million percent, 100%. Yeah. So actually, I don't know how many viewers are from the UK, but I'm obviously based over here in England. In the north of England, near a city called Manchester, there's a phrase over here. We talk about a Manchester screwdriver, and a Manchester screwdriver is a hammer. It's like there's a screw hammer. But data warehouses had great benefits. They were structured, they were governed, they were familiar, they were fast for the right types of workload. That sort of structured, we're talking about the fact that we have that well-defined schema. From the governance perspective, was ACID transactions absolutely 100%. I've got a slide in a little bit that explains what ACID is, because people say it all the time, yeah, ACID transactions, and I think a lot of people are like, okay, yeah, ACID transactions, and they don't actually know what it means. So I've got a little slide on that that'll explain that as well. Familiar, because SQL's been around forever, so people were comfortable with it. And for the right workload, they were fast. Whereas data lakes, this flexibility with your schema on read, so you didn't have to potentially spend all that time designing your pipelines and getting your ETL in there. So you could do things in theory quicker, but from a repeatability perspective, I don't think they necessarily work quite so well. But storage was cheap and also really, really scalable. So you weren't talking about having to, buy new, buy another blade for your virtual server when you needed to scale out. It was all sort of good from that perspective. And again, for some jobs it was good, but for others it wasn't. So I guess like the next stop on the evolution was this concept of the modern data warehouse, which is basically the first attempt to try and marry the two worlds. So people started to organize their data lakes a bit better. And this idea of, well, we'll land all of our raw data into the lake, and then we've got like a nice sort of audit of what our data look like, and we can keep like a copy for every day, and we'll be able to sort of replay that data if we ever need to, and we can get it in there quick, so that from an experimenting perspective we can do experiments and our data scientists will be happy. But then a little bit slower over time, we can then port it out of that lake into our structured database and into our data warehouse, and then that can serve our BI and analytics loads. So this was kind of, I think, the first attempt to try and get these two worlds to meet but it was almost kind of, I don't know what's the best way to sort of describe it. It was
Disconnected.
yeah, definitely. It was like sort of saying you've got your peanut butter and you've got your chocolate, but actually you were still just eating I was going to say a Yorkie bar. A Hershey bar and a jar of Skippy.
Yep.
It wasn't actually a Reese's cup. It was just the fact that you stuck your chocolate bar and your jar of peanut butter in the same room together and kind of tried to make them be friends.
Did you ever see those commercials? This is going to be dating me. Like, you got your chocolate in my peanut butter. No, you got your peanut butter in my chocolate. Well, I got a feeling we're about to have that moment with the history here. So keep going.
Yeah, totally. It was part of the evolution for me. It got us closer. Again, you still have that separation of storage and compute in the Lakehouse area of it. Your warehouse, you were still tied in to your storage and your compute. You were still going to stick that into a relational database management system. If you're going to use PLSQL, it had to be an Oracle. If you wanted to use T-SQL, it was going to be SQL Server, all that kind of good stuff. And so now comes the point where we can talk about what enables the Lakehouse instead, in terms of this idea of the fact that actually part of the reason we couldn't really get that integrated structure is this idea of ACID compliance and ACID transactions. And this, like lifted from the Databricks website, explains it. So when somebody says to you ACID transactions, now you can tell them, oh, you're talking about I can't say atomicity, consistency, isolation, and durability. So these are the things. And lakes didn't have this. I only found this out relatively recently because I was never really a lake fan anyway. But if a pipeline was running data into a lake and it failed partway through, didn't have any way to know at what point it had failed and whether or not like it should roll transactions back or not. In a database, yeah, you have that level of governance. So a transaction fails, it's fine, it just rolls back, and then you can kick off your ETL pipeline again, and you know that your data is going to be a good place. You're not going to be introducing partial or corrupt data and all those kind of things into it. And that's good. Those two separate architectures. The game changer is the new breed of file formats, effectively. So my next slide is talking about the Delta format. So Delta format is it's another open source project that Databricks started. Delta format tends to be the format that you'll see being used in a Synapse Lakehouse as well. And this effectively is it's file formats like a data lake, but with ACID compliance, so it can give you that atomicity, consistency, the I and the D. Durability, what was the I? It was on my screen a minute ago, I've forgotten it already. Yeah, it gives you that. So the way it works is still under the hood, it's still Parquet files.
Isolation.
So people talk about, there we go. People talk about Delta being a file format. It kind of isn't, because the file format is still a Parquet file, but it actually creates a separate set of metadata that sits alongside it that has a log, so that it can basically preserve those ACID properties. And the fact that you can now have that, and I guess one of the points I wanted to make is that whereas you'll probably find that Delta is the one that gets discussed most, there are others out there. So you've got Apache Hoodie and you've got Iceberg. So people that might have come across Snowflake as a vendor, Snowflake are all over Iceberg. I don't know if that's because they think it's a better file format, or the kind of snow and ice thing just worked for their marketing. Who knows? Hoodie's kind of the more emergent one as well. And they're variations on the same theme. It's a file format so that we can store our data in files, but with additional metadata that's going to give us those ACID transactions.
Well, and
so
it's because we're storing this stuff in files that gives us that cross cloud compatibility, right? That allows us to move stuff around, right? And cross tool compatibility. So
exactly that. So yeah, like you say, whether or not you're storing it in Google, or you're storing it in Amazon S3, or it's in Azure Data Lake, it's just a file. So somebody once said to me, databases at the end of the day, that's just all files as well. which is true, but they're just a little bit more proprietary and locked away. And like when we look at tables and databases, yeah, it's an abstraction on top of some files, but it's not like you can really dig into those files and query them to your heart's content.
You can't
This is
go
very much
browse
a
into those files on with other tools. It's you're using SQL.
exactly,
It's and yeah, yep.
yeah. Lakehouse gives you that. Here's some files stored. Like you say, query them with Databricks, query them with Synapse Serverless, query them with Dremio. I don't know how many people have come across Dremio, but that's like an open source like Lakehouse tool as well. I'm trying to think if there's any other vendors out there that come to mind, but yeah, you can get yourself in there. So this is where we land basically in terms of the Lakehouse. We no longer have to have, so the storage and the compute is still separated, but it's at the same time it's a little bit more integrated because we can use the same storage and compute for both types of workloads. So you could separate this out. You could say I want to run my machine learning with Databricks and I want to use my Synapse serverless for my BI analytics loads. But ultimately, you can still build it all into one platform and have it unified, whilst at the same time having that flexibility to sort of say, yeah, actually, Databricks, don't want to use that for my computer anymore. Let's plug something else in.
Okay, hang on before you click on anything. We have 2 questions from users, and I have an observation that I'd like to hit on here. First, my observation is thank you so much, Johnny Winters, for using raw, base, and curated, or any other names other than Databricks' god-awful naming standards where they recommend bronze, silver, and gold.
So you told me not to click, Chris, but I'm just going to have one click.
Ah! So I hate
it. but this comes from exactly the same place. So we at Advanced Analytics, we don't call it bronze, silver, gold.
Okay.
We like to use things that are more descriptive.
Yes.
But because bronze, silver, gold has become so recognized in the industry, so we don't. We call it raw base and we call it curated. We sometimes adapt that for our customers. So I've got a customer I work with at the moment. They call it raw, standard, and warehouse. Because
sure.
that's how they want to describe it. But yeah, bronze, silver, gold. Bronze is supposed to be your dirty raw data, but silver and gold aren't necessarily one better than the other. They're just for different workloads. You know, silver's cleaned, gold is cleaned and aggregated and modeled. That's the other thing.
And frankly, I think many times in many places, the bronze may contain the most golden value that you might have inside your data lake. You just don't know it, right? And so I dislike that. I'll take any other naming convention. I use a slightly different one, but I'm not going to go into that because it doesn't matter, right? Like yours is equally as good versus compared to bronze, silver, gold. So on that. So quick 2 questions from viewers. We had one question from Christian. He asked, what are the best tools when it comes to navigating and reviewing a data lake, data swamp? Is there something like a hovercraft, he asks?
Well, so we're talking for an existing lake that's become a bit of a mess already, I guess.
Mm-hmm. Yes.
Do you know what? I'm so late to the party that I've never had to. So my lake experience, having resisted for so long when I was in my earlier career because I just didn't like it. Most of my lake experience now has been part of Lakehouse implementations, and we put a lot more thought. We put a lot more thought into our structure so that we avoid that swamp scenario. Now, if I wasn't to browse data, I would, and this is best tools. There's going to be some kind of decisions you're going to make in terms of vendors and things like that. So Synapse serverless, I'm pretty certain you can just mount it to you have it mounted to a lake. You can use external tables. You should be able to browse effectively folders of files as if they're tables in Synapse serverless. I tend to use Databricks SQL because I'm just in a Databricks world. And actually, I mentioned Dremio before. So actually, I used to use Dremio in a prior role. It wasn't so much on lakes or lake houses. We actually used to use it to consolidate different SQL sources, and it was only ever for exploration we used it. We didn't even actually use it as our kind of enterprise tool or our entry point for our analysts. It was just I had a desktop version, and so for that kind of ad hoc analysis, that can work as well. I don't know if it's still there. There was a Dremio Community Edition that you could download and play about with, which might be a good idea. But so I'm like, we need Kev Arnold and the It Depends jar, don't we? Like, there's my dollar.
Yeah. Excellent point. And you're exactly right. Today, I don't think there is one tool that is necessarily the best. There's a lot of them that are competing and doing fairly well in this space, but yeah, I don't know if there's one best tool for that. And then last question before we continue on, Kevin asks, and I have an opinion on this too, but I want to see where you take this, Johnny. Kevin asks, is there considered a best practice to store all possible data inside the data lake, or is that what creates a data swamp?
I think that you should always be intentional in terms of what you're storing. I think that is the way to make sure you don't have a data swamp, so that you know what you're storing. You're not grabbing everything and throwing it in there, for want of a better term, willy-nilly. That sounded very British. So I think you should always be intentional. I think this idea of so again, putting my Power BI hat on, and this idea of keeping my model really, really, really lean and only ever bringing in the things that I need. I think in data lakes and lake houses, there's more of an argument for bringing more through. So definitely when I tend to bring a table into my raw layer, I'll bring through whole tables and I'll bring through every single column. And some of those columns may have no value at this point in time. And possibly as we move through our lake layers and we sort of say, right, well, we've landed it into raw, now we're going to clean that up and have a version of this data in base, then those columns that have never ever been used and have got zero value may get left behind, and I won't bring those into my base part of my lake. So I'm not sure if I'm answering the question quite with that, but kind of be intentional, like know what you're bringing through, because you want to be able to, even in that raw layer, you want to be able to structure which tables and what sources they're coming from and know the origins of all the data. But in terms of bringing more than you might need, thanks, Chris. then yeah, that's kind of almost one of the ideas with it. Almost the fact that you kind of have that sort of, more than you would have brought into a data warehouse traditionally. We used to transform our data warehouse. We used to stage things that had been sort of transformed before they hit stage to an extent as well. Whereas this is bringing it through in a much more raw state and being able to go back.
So
some of them.
Before we move on, and I want to put a cap on this answer so Kevin can know. My contention is that every file on your network should be considered part of your raw space. And that's inclusive of every desktop, every laptop, every OneDrive folder, every place where data exists should be considered a subset of your raw that just has not been mapped into raw yet. So that is my position. It should be separated off as like a swamp area potentially. Like you've got your defined, processed, managed raw area, but then you have your swamp, area that is your raw space. So that's my contention and the way I think of it, because the amount of data that exists inside of organizations and companies is far larger than we as data professionals typically consider. And I think we need to be expanding our view of data to be everything that may be out there, good and bad.
I think another sort of point to that is that, again, going back to Databricks being marketeers and this bronze, silver, gold idea, that ends up being almost a bit of a constraint that people think they need to have bronze, silver, gold. And then I've heard people being like, oh, well, we're going to have platinum as well. That's going to be a stage beyond gold. But actually, in a lot of the lake houses we implement, we have more than 3 layers. We've had some implementations where we've had a landing layer. And so in our raw layer, we tend to still convert everything to be Delta format. But quite often we'll have a landing layer that sits before raw that is completely untouched. So if you're getting JSON files or CSV files, it's absolutely completely like unadulterated raw data, versus that still, other than the fact we changed the format, we'll then convert it to Delta. And also we end up sometimes getting layers in between our base layer and our curated layer. We have an enriched layer where it might, whereas our base layer tends to be raw data that's been cleaned, and then our curated layer is where we still do. It's like a data. It's a data warehouse, but on different technology. So we still tend to use like Kimball principles and dimensional modeling. But sometimes it's good to have something that sits in between, where you might actually want to mash up a couple of different data sources and do that before you actually aggregate it into that data warehouse layer as well. So by kind of straying away from that bronze, silver, gold naming convention, you can open it up to having like lots of different layers. And I actually went to a really, really good talk last year at SQL Bits, a guy called Luke Mahoney, who works for Microsoft in this space. And he sort of said that it's still a bit of an emerging practice. So I think personally think that Lakehouses are here to stay. Best practices are still a little bit fluid. And he sort of said that, like, don't be constrained by exactly what Databricks say or exactly what Johnny says, or what advancing analytics say. It's all about using the technology to meet whatever your requirements are and doing it your way. So yeah, even this little diagram here, as I say, this kind of was trying to capture the fact that we have this curated layer, and we still use dimensional for our implementations. We still use dimensional modeling principles. Heard of people who like to have a data vault layer as well. I've gotten to the point now where we've had a serving layer that's sat out beyond curated, whereby we've taken our curated layer might still actually be quite wide in terms of the attributes that we bring in, and then we'll slim that down for something like a Power BI implementation. So again, in my curated layer, I might have like audit columns, like inserted dates and updated dates, and I might have primary keys on my fact tables, for argument's sake. And I don't want any of that for analytics uses. So sometimes we have a layer on top of that as well that kind of abstracts that curated layer even further. So there's no right and wrongs. There probably are wrongs, but there's not necessarily one right.
Right, and to build on that, I think you have to look at what your needs are of your organization, right? Do you need that enriched layer where people are potentially doing write back, right? You know what? Those numbers aren't exactly right. They're an amalgam of 14 systems, so changing any one of them won't yield the right results that it needs to be. So we're going to do some write back capabilities. Well, you can force it into the structure, or you can create another layer that takes that into account. Same thing with like API layers, like you were talking about. Like an API has to be down dirty and fast and scalable, right? You have to be able to handle 1 million hits a second. Well, you don't want your data warehouse taking 1 million hits a second, and if your tables are too wide or too deep to get that stuff, that's not going to work either. So yeah, it's very situational. We have to there's still work here, right? We still have to do the job of going through it and building these things in place and managing them. So excellent. Keep going now.
No worries. In terms of history of the platform, this is kind of it. This is where we got to. We've got one sort of unified platform and set of technologies that you can still mix and match. You've still got a separation of storage and compute, and you can make it almost modular, but it's still unified in terms of making sure that we're pushing through both our business intelligence and analytics workloads and our data science workloads through that as well. It still sticks to tried and tested data warehousing type principles as well, and it just becomes almost like the one-stop shop for everything. That's kind of where I got to in terms of like that brief history. I think there's a few good talking points. So we said we'd stick a pin in that. What's the right size for organizations that want to use this? quite interesting, I guess, because from a so this is true life story. Working for a consultancy before I worked for Advanced Analytics. Advanced Analytics, we work with some really big clients. I think I mentioned before I've been working with Hershey recently. The consultancy I worked for previously was smaller, and our clients were small, medium enterprises, and they weren't so big. And we had this thing where it was like, does it make sense to implement a Lakehouse for businesses that are this size? Because it just feel like a bit overkill, really, because they don't really have the volume of data. And should we go down the route? And we did a bit of experimentation with it, and we kind of found that from a cost perspective, it was neither here nor there. So, like, if you can imagine, we were doing quite small scale BI implementations, and we used to use Azure SQL database, which is kind of like, we weren't using SQL Warehouse or Synapse Dedicated. We were using Azure SQL database, and that's an always-on resource in Azure. You can't switch it off. You can play about with scaling it to possibly save costs, but it's got to be always switched on. Whereas with a Lakehouse pattern, you need to store your data in the lake, but lake storage is cheap. But from a compute perspective, you use what you need. It doesn't have to. It can just be off and completely lying dormant when it's not getting utilized. So we ran a few different experiments, and we kind of found that at the lower end of the volume scale, from a price perspective and from a performance perspective, it was pretty much the same. There wasn't really much difference. Again, it falls into, it depends. If they had data savvy people that were going to be querying the data on a regular basis and doing analysis using SQL queries, then potentially a database might be better for them, because even though it's always on, actually, if they're using it a lot, that's fine. If they're using something like a Power BI self-service model, where basically you're landing it into your warehouse and then loading it into Power BI, well, after you've loaded it into Power BI, your warehouse still had to stay on, whereas your compute in the Lakehouse scenario didn't. So it worked really, really well for them. And what we kind of sort of came to the conclusion with was that if we, even at a small scale, if we go with Lakehouse, it's still scalable later. It's still actually, if here and now, if you're a large organization with loads and loads and loads of data, Lakehouse is probably starting to emerge as the de facto architecture that you like to go for. If you're much smaller, your volumes of data are low, your use cases you don't really have any data science use cases. Fitting that all into, something like Azure SQL database, or maybe even going, Postgres on EC2 or something like that, that will probably work for your workloads. But what happens if your product goes viral, and in 6 months' time, all of a sudden, whoa, we've hit the big time here. We've gone from 1,000 customers a week to 1 million customers a week. Lakehouse architecture is going to allow you to scale quickly, so it kind of gives you that future proofing. That's effectively where we landed with it.
So, and Johnny, to build on that, that's exactly why I say if you have 100 people or more in your shop, you should be really looking at going the Lakehouse pattern, because the number of businesses that fail because they're unable to scale appropriately to meet their customers' needs is staggering, right? They get capped at a certain size, and because they can't adjust their tech, they can't adjust their resources, they can't adjust. They can never get above it, and that can actually lead to the businesses going under, because they get this sudden demand that they can't meet, and then they have huge problems. So that's why. And Kevin, $1 went in the jar, so we have another depends. But I think that what you should be doing, the recommendation on if you should be going Lakehouse or not, is coming way down to the point where, I mean, honestly, soon it's going to pass into that $100 or even below 100 users. Just say, you know what, just go with the Lakehouse architecture. Even if you don't need the data science stuff today, someday you may, and someday you may want to look back upon that raw data that you had today to help you understand what's going on in the future. And if you start to adopt it now, 10 years from now, you could say I've got 10 years of history in my raw layer, my data lake house, versus, well, I've got the last 6 months of aggregated data or whatever it is you happen to have captured inside of your data warehouse. So excellent
It's
point.
here. I do think it's here to stay, but probably in 10 years' time, we'll probably be talking about data aquariums or data birdhouses or something like that. Who knows? And I think, yeah, I just think it gives you the flexibility for different workloads, different scenarios, scalability, and yeah, portability as well. In terms of like shifting things around. So yeah, I think it's here. I guess there's a couple of the things that I was going to mention, like when I was talking about the misconceptions. I came across some guy who was basically arguing that lake houses will never replace databases, and I was like, yeah, databases are still a thing. That's fine. We're talking specifically for analytics workloads here. We're not looking to replace OLTP systems and transactional systems at all. This isn't what this is about. This is all analytics workloads, so data science and BI workloads effectively. So that was a bit moot. I think the other sort of interesting discussion to get into is I think one of the benefits of SQL is we talked about familiarity and the fact that SQL's been around forever. And I think some of the reluctance with Lakehouse is potentially around the skills gap because there's SQL engineers are 10 a penny, but Spark engineers, because Spark is ultimately well, for Databricks and for Synapse, really, that's the engine that a lot of it's built on. And Spark engineers aren't as common, and like they can potentially be quite expensive. I think for me, that becomes an education piece that like the more people that can become familiar and comfortable with the technology, that's going to drive the market down in terms of we're going to have more people. So the fact that there's only, I don't know, a dozen good Spark engineers in the world, that's obviously a silly number. That's not what I mean. But, okay, let's have hundreds of
It's
them. And
way
then,
too large. It's much smaller than that.
yeah. So I think,
I met the
yeah,
three guys that one time. They were.
so yeah, I think personally, I like the idea of trying to embrace the change and roll with it and learning about all this stuff as opposed to sort of fearing it because it's different to what we've done for pushing 30 years.
Well, and so to build on that, we're basically, when we talk about a lake house, we're talking about a structure that combines a data lake where we've got distributed files that are out there so that data scientists can work and operate. But we also still have our data warehouse that's just part of that lake house, leveraging similar technologies, similar concepts, but pulling forward and pulling in all of the things that the data lake never had in the past, and putting it into the same platform, right? So that you kind of have the best of both worlds in a scalable solution that is cloud agnostic. I mean, we've talked about Synapse, we've talked about Databricks, but you've also talked about GCP and Snowflake and these other tools that are out there, right? So this is a great pattern to start to develop, because you can really flip around and try different things, right?
Yeah, absolutely.
Well, and what do we say? So when the data aquarium, it does become the standard, and you need your data goldfish as your big tool, and the bubbler for oxygenating your aquarium. You'll be able to do that with the same data files. There won't be a big conversion at that time, right?
Exactly. When you're in your goldfish layer.
Well, that was good. That was impressive. Well done, sir. All right. Well, we are getting near time. I wanted to, before we go, I just do want to do a quick little promo for next week. I've got Bernat. He's going to be joining us next week. He's going to be going deep into Power BI parameters. I think he mentioned something about calculated columns too. So do join in on that session. I'm really looking forward to speaking with him. We're going to do a similar like Q&A. This is something we're going to be doing every single week. Normally Wednesdays at noon, but I've got a special event that's about to come up. More on that once it gets announced. I can't wait to show you guys what we have coming up. But
I know what it is.
Yeah, thank you, and thank you for being flexible to cover that. So, cheers, Johnny. And thank you all for joining us today. Really appreciate you coming out. Really appreciate you asking us questions and being part of the community. Really enjoyed connecting with each and every one of you. Johnny, do you have anything parting words?
Go Lakehouse. It's the future. Go with it. But
Yeah.
thanks very much for having me on as well, Chris. It's been a pleasure.
Oh, yeah. Always happy to actually. I think this is like the first time we've been able to like communicate and talk, and so it's great. I'm a big fan of your stuff, so excited to be able to work with you more closely. So this is awesome.
Feelings mutual.
Oh, awesome. Well, thank you guys all very much. You guys have a great day. Peace. Baker Tilly Digital combines strategic industry insight and advanced technical expertise to uncover and solve your digital transformation challenges. If you're interested in learning more, check out our website at bakertilly.com/digital.